Hey guys, welcome back to another video with Iyanla Empowers. In today's video, we'll be doing a fun topic. We'll be doing planetary science. Yay! And this is a very interesting topic for those who love astrology and outer space and rocket ships and being an astronaut and whatever the case is. We're just going to introduce you to some topics here today. Before we get into the video though, please remember to like, share and subscribe. Tell everyone to check out Iyanla Empowers and watch her geography videos. Okay, now we can get into it. Now, before we get into anything deep, we're going to define some terms to understand the basis of planetary science. Now, the first term that we're going to define is the universe. So we always hear about the universe. What is the universe, right? So the universe is all of space and time and their contents, which includes planets, stars, galaxies, and all other forms of matters and energy. And if you want to know what is a planet, what is a star, what is a galaxy, we're going to get into that. But it's just to know that the universe houses all of these contents, and it's just space and time and darkness, and it's just amazing. Alright, but what is a galaxy? Well, the galaxy is a system of millions or billions of stars together with gas and dust, which is held together by gravitational attraction. So we're going to be used to gravitational attraction, gravity, we're going to be used to all of that because that is the basis of how our universe is, even made by gravity. So everything is held in the universe by gravity. So gravity holds this system together. There's a millions of or billions, they said, of stars, which mix together with gas and dust, which is held by the force of gravity. So that is simply what the galaxy is. Now we are commonly familiar with the Milky Way galaxy. So every time we say galaxy, we always match it to the Milky Way. We can think about the chocolate, and usually when we talk about chocolate, we still think about the galaxy. Alright, so this houses the solar system. So this Milky Way galaxy houses the solar system. So this is very, 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 it makes you think. It really does make you think. Alright, let's talk about the solar system now. So the solar system is the gravitationally bound system of the sun and objects that orbit it either directly or indirectly. And as I said before, gravity is the basis of the universe. Everything is held together by gravity. So the solar system is a gravitationally bound system, and it consists of the sun, which is basically in the center. Then you have objects that orbit it, and you can either orbit it directly or indirectly. Now, of the objects that orbit the sun directly, the largest are the 8 planets, with the remainder being smaller objects like dwarf planets and smaller solar system bodies. So what orbit the sun directly are planets. The largest are the 8 planets which we know, and we also have some smaller planets which we call the dwarf planets, and then we also have small other bodies that occupy the solar system. Now it goes on further to say that the planets of the solar system are, and it gives you in the order of the distance from the sun: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And we can create a little acronym, so MVE, MJS, UN. Wherever you can remember it. But what is a planet though? Well, a planet is a large round object in space that moves around a star. And in this case, in the solar system, this star is the sun. Now, it is a celestial body that is in orbit around the sun, which we mentioned before. And celestial just means belonging out of space. It has sufficient mass for its self-gravity to overcome rigid body forces. So it assumes a hydrostatic equilibrium, which is a nearly round shape, which means its mass is enough for gravity to keep it in place, so there's nothing that can come into its space, so it overcomes rigid body forces, and it assumes this nearly round shape, which is the basis of it being the right weight, the right mass, the right size to be held by gravity. That's simply what it's saying. Now, I mentioned before dwarf planets. Now, what is a dwarf planet? This is a celestial body, so it's still belonging outer space, and it also orbits the sun. and it has a spherical shape, but it is not large enough to disturb other objects from its orbit, and this is why it cannot be classified as a planet. So because of its size, it's not large enough to, disturb other objects from its orbit. And we can think about it. So for example, imagine two guys. You have a big, tall, stout, muscular guy, and you have this small, tiny, slender guy. And this big tall guy says, don't come in my space, and you're not as big as this guy, so eventually you won't go into his space because you don't want anything to happen to you, right? But if this small tiny guy and you're bigger than him and he says, don't come in my space, you just push him one side and you go into space same way. So you can think about it like that. So is that they're not big enough for persons or objects to not come in their space. So this is why they're classified as dwarf planets. Alright, now let's talk about a star. So a star is simply a large ball of burning gas in space that is usually seen from Earth as a point of light in the sky at night. So stars are usually visible at night, and it's simply just a large ball of burning gas, like it's just gas burning in space. And we know that the largest star that we know is the sun. And I have in brackets, twinkle twinkle little star, twinkle twinkle little star, how I wonder what you are. Yes, right, just for you today, yeah. I can even remix it and say, twinkle twinkle little star, large ball of burning gas in space, to get to remember it, okay, or maybe not. Anyways, alright, let's talk about a meteor now. So now we're entering the M zone, and I like to talk about these 3 M's, and I'm going to go into order, and I'm going to also allow you to get what I mean. So we have a meteoroid, and this is a small body of matter moving in the solar system. So it's just a small body of matter. Matter, solid, liquid, and gas. So it's solid, and it's moving in the solar system. And it would become a meteor if it entered the Earth's atmosphere. So when it enters the Earth's atmosphere, it is now a different name. It's classified as something different. So let's just talk about what a meteor is. So our second M. This is a small, which is a meteor, sorry. So this is a small body of matter from outer space that enters the Earth's atmosphere, becoming incandescent. And this simply means emitting light as a result of being heated, and it's being heated as a result of friction. So because of this, it will appear as a streak of light, and we always call this a shooting star. So we know that shooting stars can be rare, and every time we see it, I always say, look at that, make a wish. So we think it's just a star that's falling from the sky. Well, we would say from the sky, but it's actually a meteoroid that is entering into the Earth's atmosphere. And because it enters into the Earth's atmosphere, it is now classified as a meteor. And as it enters, it begins to emit light, and it starts to emit light because it's being heated as a result of friction. So it's passing through these dense layers of atmosphere. So because of that, it's creating because it's creating friction, it's appearing as light. So it's a streak of light that we see, and they say, look up, make a wish. So every time you see a shooting star, remember that it's a meteoroid that has entered into the Earth's atmosphere, not classified as a meteor. So you can just say it's a meteor that's going on. Alright, so on to our third M, we have a meteorite. So it's no longer D but an E now. Now, a meteorite is a solid piece of debris from an object such as a meteoroid that originates in outer space and survives its passage through the atmosphere to reach the surface of a planet or a moon. So a meteorite is when it reaches to the Earth's surface now. So we had 1 when it was in outer space, 2 when it was passing through the Earth's atmosphere, and 3 when it actually meets Earth, meets the ground of a planet or of the moon. Now, it says survives its passage because as it passes through the atmosphere, through these dense layers, because of friction, it's being broken up, broken apart, and who knows where it goes. I don't know where it goes. Maybe someone who knows astrology can tell you, but sometimes it survives this passage and it reaches to the Earth's surface, and when it's at the Earth's surface, it's no longer known as a meteoroid or a meteor, but a meteorite. So that's just a classification that is given to it now. So let's go through the stages again. We have a meteoroid, floating in outer space, then it decides to enter into the Earth's atmosphere, and it's now a meteor. And then if it survives its destination, yippee, reaches on the surface of a planet or a moon, it is now classified as a meteorite. Also, it can also be an asteroid or a comet that makes it onto Earth, and it's still classified as a meteorite. So it says from an object such as a meteoroid. So it can also be from a comet and an asteroid, and we're going to just talk about those as well. Now let's talk about an asteroid. So asteroids are small rocky objects that orbit the sun. So these orbit the sun indirectly. Remember, solar system had objects orbiting it directly and indirectly. So directly we had our planets, dwarf planets, large planets. And now indirectly we have our asteroid, which is just orbiting the sun like planets, but they are very smaller than planets, and they are rocky objects. And also, if this is supposed to go through Earth and reaches to the surface of not just Earth, but through any planet, reaches to the surface of a planet or the moon, it will be known as a meteorite. Alright, so now a comet. Now, comets are small snowballs of frozen gases, rock and dust that orbit the sun. So unlike an asteroid, which is rocky, a comet is frozen. Alright, so the difference between an asteroid and comet, we can point out already, is a asteroid is rocky, while a comet is snowballs of frozen gas. Alright, so when frozen, they're the size of a small town. So when they're frozen, they're little cute things that's orbiting the sun. However, when a comet's orbit brings or is close to the sun, I should say, it heats up. So it's now excited, it's now blossoming into its true form. And when it heats up, it spews dust and gases into a giant glowing head larger than most planets. So you can imagine it started out that it's a small, like a tiny frozen thing, referred to as a small town. And then it gets it just gets a boost from the sun. Now it's now boosted by the sun. So now it heats up, it's excited, and now it's just spewing dust and spewing gases, and it turns into this giant glowing head, which is now larger than most planets. So its ability to transform when in proximity of the sun is amazing. Okay, alright, so now let's move on. So now we're talking about the moon, and we love to see the moon, especially it's visible in the night. Now moons, which are also known as natural satellites, they orbit planets and asteroids in our solar system. So planets orbit the sun, moon orbits planets. Okay, so let's just get a classification out there. So moons do not orbit the sun, but moons orbit planets. So it's kind of like a cycle, like a domino effect kind of thing. So you have planets orbiting the sun, moons orbiting the planets. Alright, and they also orbit asteroids, which we say are rocky, smaller than planets, and they orbit the sun. So they orbit planets and asteroids in our solar system. Now the Earth has one moon, so the Earth only has one moon. So the moon is very special to us because we only have one of them. But there are more than 200 moons in our solar system. So did we think that we were the only ones with a moon, or did we think that there was only one moon in the solar system? No. You had a different thought, because you have more than 200 moons in our solar system. There was one point when I thought that there was only one moon in our solar system, but eventually I learned that that wasn't true. Now a moon is visible chiefly at night because it's now getting reflected light from the sun. Alright, so this reflected light from the sun, so when there's sun in Europe and it's night here, that reflected light, we are seeing it, and that's how we see the moon in the night. And it's vice versa when we are experiencing night and somewhere else is experiencing day. Alright, so that's our moon.